So I'm going to number these so I don't have to count every time. Okay, so point A is -4 in the real direction plus 0i in the imaginary direction. So you could just write -4 as the coordinate for A. For B, that is at 0 plus 4i. Again, you could leave off the 0 and just have 4i. C is at 5 plus 2i. And D is at 4 minus 3i. Okay, so what types of numbers are these three? Root 3 is a real number and complex. The square root of -9, that's 3i. So that's a pure imaginary. And it's complex as well. And then 5 plus 2i, that's just complex because it is involving the real and the imaginary together. Okay, I have to add like terms. So 3 and 5 is 8. And 2 plus -7 is minus 5i. When we multiply, I'm going to distribute the 5 to both of these pieces and the -6i to both of those. We can combine these like terms, and I squared is -1. So this term is -6 plus 5, so I have -1 minus 11i. So we're going to do the same thing for 39. 8 to both of those, -2i to both of those. So 8 times 8 and 8 times 2i. Then -2i times 8 and -2i times +2i. These cancel each other out, they're opposites. I squared is -1, so this is really +4. And 68 is our answer to number 39. Now 40, when you square a quantity, that means it's times itself. You cannot distribute the square. Do not do that. So I got to multiply these together. Again, I squared is -1. So I have 4 minus 49 is -45. And then -14 plus -14 is -28i. For 41, we have to simplify and get the I out of the denominator. So we're going to multiply by the complex conjugate. So on the top, the 7i gets multiplied to both of those terms. And on the bottom, we have to multiply. And the whole reason we pick the conjugate is so the middle terms will cancel out. So if they don't, something's gone wrong. So these cancel. I squared is -1. Same thing here. So when I start simplifying this, I'm going to write this as -7 plus 14i, so it's in standard form. And then this is going to be 4 minus -1 for 5. To write it in standard form, I'm going to split it up so that I can clearly see my A plus BI. So we're going to do the same thing for 42. You know, multiply by the complex conjugate, the top and bottom. So we can think of this as a double multiplication problem. 2 times 1 and 2 times negative 6i, 7i times 1, and 7i times negative 6i. And on the bottom, I'm going to have 1 minus 36i squared. So I squared again is negative 1. So this is 1 minus, these multiplied will become plus. So 37 is my denominator. So this is negative 42 times negative 1 for positive 42. Plus 2 is 44. Negative 12 plus 7, so that's minus 5i. And again, I'm going to split that up so that I have it in standard form. Okay, so to finish 43 and 44, these bars, remember, they're absolute value. Okay, the bars mean absolute value, which is the distance from 0.
Attention.
So we can find the absolute value by doing the square root of a squared plus b squared. That's square root of 4 plus 9, square root of 13 is our answer for 43. Similar for 44. So that's the square root of 25 plus 144. So add those together. And we get 169. Now the square root of 169 can reduce to 13.